Okay? So you either have to have this given to you, or it's given to you like in a word problem. Then you must be given equations to use. So here we have equation number 1, 1/2 of nitrogen gas plus O2 makes NO2, and our delta H is plus 34. Our second equation, nitrogen monoxide plus half a molecule of O2 will produce NO2 gas, and our delta H for this is negative 56. So this is how you approach it. You look at your overall equation and you pick one of the reactants or one of the products. And you see how you can manipulate these two reactions to give you the correct chemical on the correct side with the correct coefficient. And all we're going to do is change these two. I suggest if you're going to pick something, it's not in both equations. Like, don't start with O2. Pick something that's only in one equation. So, pick something. Inkit. N2. So then you ask yourself, which equation has N2 in it?
The first one.
First one. Does it have the correct coefficient?
Yeah.
No.
So that's a no. Is it on the correct side?
Yes.
So we want it to be a reactant, but we want that to be 1. What would you have to multiply this by?
2.
So you multiply the entire thing by 2, and the delta H has to be multiplied by 2. So we now have 1 prime. So you're going to write this underneath, and you are going to take that first equation and you're going to multiply everything by 2. So now we have N2, 2 O2s, goes to NO2, 2 of them, and our delta H is now 68 kilojoules. Once you're done with that equation, you leave it alone. So that's done. Now let's look at equation number 2. Does it have anything in it that is in the overall equation? Sure. Which one?
Oxygen.
Oxygen and
NO.
NO. We're going to pick NO because we've got 2 sources of oxygen in this question. We've got oxygen here and oxygen there. So let's deal with NO. Is it on the correct side? No. Does it have the correct coefficient? What would we have to multiply it by? 2. And we have to flip the equation. So we have to flip it. And we have to times it by 2. So now we're going to have 2 prime. We're going to have now 2 NO2s going to 2 NOs and how many oxygens?
1.
1 oxygen. Because we flipped our equation, it was exothermic, but now it's going to be endothermic because we had plus 56 kilojoules over here, so the 56 kilojoules goes with the NO2. So now it's plus 56 but times 2, so 112 kilojoules. Did you follow what I did? Now, this is Hess's law of heat summation. We are now going to add these two new equations together. What is on the left side and the right side will get canceled. So you can do this two ways. You can do it by inspection as you go, because some of you can, or you write out all your reactants, write out all your products, and then cross out what's on both sides. So, we've got two NO2s on the left. We have two NO2s on the right, so they cancel. We have two oxygens on the left, one on the right. So the one on the right will cancel, and we'll be left with one oxygen on the left. So now we have N2 plus O2 going to two NOs, and you're going to add your delta H's together. And that is how you find the enthalpy change for your reaction. Double check, do I have the same chemical equation as the given equation? Yep. Do I have now, and you add the new delta H's together, and you've got your enthalpy change for this reaction. Any questions? Then let's do another one. So you're good? Yes or no? We don't know what our delta H is. Is it balanced? 2 carbons, 6 hydrogens, 1 oxygen. All right, so equation number 1. What do you want to look at it for? What do you want to look at it for?
Ethylene gas.
All right, C2H4. So you ask yourself, is it on the correct side as the overall? Does it have the correct coefficient? So then that's good. That one's good to go. All right, now let's look at equation number 2. What do you want to look at it for?
H2O.
I wouldn't pick H2O because it's in both equations.
C2H5.
Okay, so let's go for the ethanol. Is it on the correct side?
No.
So we have to flip it. Does it have the correct coefficient?
Yeah.
So all we have to do is flip it. So then you add those up. We want to get zinc sulfide, 3/2 oxygen, zinc oxide, and sulfur dioxide. Once we get our delta H, we can figure out the second part of this question. So, pick something. Salma, pick one of the compounds.
Zinc sulfide.
Zinc sulfide. Okay, so we're looking at equation number
1.
3. So is zinc sulfide on the correct side?
Yes.
Does it have the correct coefficient?
Yes.
All right, so 3 is going to be good to go. All right. So 3's good. Okay, Brandon, pick another substance.
ZNO.
ZNO, so zinc oxide. So, which equation are we looking at?
Number 1.
Number 1, is zinc oxide on the correct side?
No.
Does it have the correct coefficient?
Yes.
So all we have to do is write out equation number 1 again, but flip it. Oops. because we flip it, it went from an endothermic reaction to an exothermic reaction. So that leaves equation number 2. Yep.
Is there such thing as like picking the right element and like molecule to like analyze or like?
Yes. Don't pick, try not to pick something that's in more than one equation. Find something that's unusual, because then the rest of it will fall into place. If you pick something that's in 2 places, there's different ways you can manipulate it, and you lose track of what you're doing. So, what would you pick from number 2 that's in the overall equation?
Could we go SO2 or S or O2?
Well,
I'll go
the-
SO2.
SO2 is a better choice only because we already have an O2. So that one, oxygen, will work its way out. It will have to. So it's easier to focus on just one compound that's in the overall. So we're going to go with SO2. Is it on the correct side? Does it have the right coefficient? All right, so then it's not prime, it's just equation number 2. So we've got S plus O2 goes to SO2, and our delta H is negative 296.8. Now, add these equations up and see if you get the right answer.
When you're canceling out, do you only cancel, when you cancel one thing out, it has to cancel out from another side, on the other side of the reaction?
It will only cancel out if it's on opposite sides.
So if you have 2 of the same things on the same side, they add?
They're going to add. Yep. So zinc can cancel because it's on the left side in equation 1 prime, and it's on the right side in equation 3. Sulfur can cancel because it's on the right in equation 3 and on the left in equation 2. So we have,
I'm confused about oxygen.
oh, but you've got a half plus 1. Can you write 1 as a fraction?
1 over 1.
1 over 1, or, so you can add fractions, you have to have the same denominator.
Okay.
So this is really 2 over 2. Did you get that answer? 441.3 kilojoules?
Right?
Is that correct? All right, so now we're not finished this question. The question said, how much energy can be obtained from the roasting of 50 kilograms of zinc sulfide ore? What do we know from this thermochemical equation? We know molar enthalpy in terms of zinc sulfide. What's the coefficient in front of zinc sulfide? 1. So our molar enthalpy, is negative 441.3 kilojoules, and there's 1 mole of zinc sulfide. So now you have to find out how many moles are in 50 kilograms of the ore. What's the mole? Yeah.
Is delta HX the negative 441.3? Or is that delta H?
It's delta HX, because we took our delta H from our reaction and we divided it by 1 mole of zinc sulfide. So that is our delta HX, yep.
You have to show that step before 41.5.
I would do that because if you just say, oh, okay, that's kilojoules per mole, but you forgot to look, it could be that you've got a different number other than 1 in your thermochemical equation. So I wouldn't skip that yet, because that happens a lot when I'm marking assignments and tests. Okay, so then what's the molar mass of zinc sulfide? 97.48. So you take that, that will give you moles. Multiply it by negative 441.3 kilojoules per mole. Because we have just plugged it into delta H is N delta HX. And that will tell you how much energy is released from 50 kilograms. So it should be a pretty big number. What'd you get, Ankit?
226,354.12.
Okay, say it again slower. My brain got the first two.
226,354.12. Negative.
How many significant digits can we have in our final answer? 3. So which 3 would you keep? The 226. Now, 1,000 kilojoules is a megajoule. So you can either change this to 2.26 times 10 to the 5 kilojoules, or you can change it to 226 megajoules. I would accept either answer, but you would have to round it to the proper number of sig figs for full marks.